Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
I'm your host, Wayne Zool, and this is a special episode of the Astro Guy podcast. This past December, NASA, the Canadian Space Agency, and the European Space Agency delivered a wonderful Christmas present to the world. At 7:20 a.m. Eastern Time on Christmas morning, the James Webb Space Telescope finally launched after years of delay. In the observatory's month-long voyage to the L2 Lagrange point, it slowly began unfolding itself. During the process of unfurling, there were 344 single points of failure that needed to be overcome for the mission to succeed. If any one motor, cable, bolt, screw, or spring had failed, the mission would have been over. But the many years of testing and re-engineering allowed the observatory to open itself up perfectly. Once it was unfurled and on orbit, it needed to spend months as the instruments cooled down to the frigid temperatures where they would be operating. During that time, engineers on Earth spent months aligning all 18 primary mirror segments and the secondary mirror, along with all the instrumentation that was on board. When it was launched, we were told that we wouldn't see any images until mid-July at the earliest, but some of the test images were so amazing that NASA released several test images months earlier than originally planned. The first images were less than stellar, pun intended. They even had the spacecraft take selfies and send them back to Earth. This past spring, we saw images of a single star that illustrated how misaligned the mirrors were. Over several weeks, the engineers sent commands to the JWST to make tiny adjustments, bringing the image from 18 random points to 18 aligned points of light. Then, through further adjustments, the 18 single images were merged into one. Once aligned, the image showed more than just a single star. There were also lots of galaxies in the background, and they were clear and in focus. Days before the first color images were due to be released, NASA released an image that should look familiar to amateur astrophotographers. The image showed stacking artifacts. This happens when you take several images of an object over time, but because of motion and tracking adjustments, when stacked, the edges don't quite line up. This is normal and expected, but besides the stacking artifacts, there were several stars, and again, lots of galaxies in the image, giving hope that when the first color images were released, that we'd be totally blown away. For several weeks, NASA had been announcing that July 12th would be the release of the first images. But early on the 11th, they announced that a single image would be shown from the White House later in the afternoon on July 11th. I tuned in on NASA TV, as I'm sure many other people did around the world, to watch as the first color image from the James Webb Telescope was unveiled. The first image revealed was a deep field image that shows about a dozen or so stars within our galaxy and thousands of galaxies that have never been seen before. This is the description of the image from NASA's website. NASA's James Webb Space Telescope has produced the deepest and sharpest infrared image of the distant universe to date. Known as Webb's first deep field, this image of galaxy cluster SMACS 0723 is overflowing with detail. Thousands of galaxies, including the faintest galaxies ever observed in the infrared, have appeared in Webb's view for the first time. This slice of the vast universe is approximately the size of a grain of sand held at arm's length by someone on the ground. This deep field, taken by Webb's near-infrared camera, or NIRCam, is a composite made from images at different wavelengths, totaling 12.5 hours. Achieving depths at infrared wavelengths beyond the Hubble Space Telescope's deepest fields, which took weeks. The image shows the galaxy cluster SMACS 0723 as it appeared 4.6 billion years ago. The combined mass of this galaxy cluster acts as a gravitational lens, magnifying much more distant galaxies behind it. Webb's NIRCam has brought these distant galaxies into sharp focus. They have tiny, faint structures that have never been seen before, including star clusters and diffuse features. Researchers will soon begin to learn about the galaxy's masses, ages, histories, and composition as Webb seeks the earliest galaxies in the universe. Wow! It was totally worth the wait. The image is stunning. It even shows gravitational lensing, an effect that was predicted by Albert Einstein. On the morning of July 12th, another 4 images were released. The first new image we saw that morning was the Spectra of Wasp 96b. Here's how NASA describes it. NASA's James Webb Space Telescope has captured the distant signature of water, along with evidence for clouds and haze in the atmosphere surrounding a hot, puffy gas giant planet orbiting a sun-like star. The observation, which reveals the presence of specific gas molecules based on tiny decreases in the brightness of precise colors of light, is the most detailed of its kind to date, demonstrating Webb's unprecedented ability to analyze atmospheres hundreds of light years away. While the Hubble Space Telescope has analyzed numerous exoplanet atmospheres over the past 2 decades, capturing the first clear detection of water in 2013, Webb's immediate and more detailed observation marks a giant leap forward in the quest to characterize potentially habitable planets beyond Earth. Wow. Then we were treated to an incredible view of the Southern Ring Nebula. Here's NASA's description. Some stars save the best for last. The dimmer star at the center of this scene has been sending out rings of gas and dust for thousands of years in all directions, and NASA's James Webb Space Telescope has revealed for the first time that this star is cloaked in dust. 2 cameras aboard Webb captured the latest image of this planetary nebula, cataloged as NGC 3132 and known informally as the Southern Ring Nebula. It is approximately 2,500 light-years away. Webb will allow astronomers to dig into many more specifics about planetary nebulae like this one, clouds of gas and dust expelled by dying stars. Understanding which molecules are present and where they lie throughout the shells of gas and dust will help researchers refine their knowledge of these objects. This image is so beautiful. I was stunned by the next one to be shown as well. Once again, here's NASA's description of the image. Stephan's Quintet, a visual grouping of 5 galaxies, is best known for being prominently featured in the holiday classic film It's a Wonderful Life. Today, NASA's James Webb Space Telescope reveals Stephan's Quintet in a new light. This enormous mosaic of Webb's largest image to date covers about 1/5 of the Moon's diameter. It contains over 150 million pixels and is constructed from almost 1,000 separate image files. The information from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. With its powerful infrared vision and extremely high spatial resolution, Webb shows never-before-seen details in this galaxy group. Sparkling clusters of millions of young stars and starburst regions of fresh starbirth grace the image. Sweeping tails of gas, dust, and stars are being pulled from several of the galaxies due to gravitational interactions. Most dramatically, Webb captures huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. I'm thinking that NASA was saving the best for last, and again, they didn't disappoint when they unveiled the next image. Here's their description. The landscape of mountains and valleys, speckled with glittering stars, is actually the edge of a nearby young star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by NASA's new James Webb Telescope, this image reveals for the first time previously invisible areas of starbirth. Called the Cosmic Cliffs, Webb's seemingly three-dimensional picture looks like craggy mountains on a moonlit evening. In reality, it is the edge of the giant gaseous cavity within NGC 3324, and the tallest peaks in this image are about 7 light-years high. The cavernous area has been carved from the nebula by the intense ultraviolet radiation and stellar winds from extremely massive, hot young stars located in the center of the bubble, above the area shown in this image. Wow. Just wow. What can I possibly add to that? Well, we only had to wait another day for some more amazing images to drop. This time they released images of Jupiter in the infrared that show incredible detail on the planet, as well as several moons, and Jupiter's rings are also seen in the image. I'm looking forward to seeing what great discoveries are going to come from JWST. I hope that you'll follow them as the world benefits from this science. To keep tabs on where the Webb Space Telescope is, and to see the most recent science data, visit web.nasa.gov. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text message or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.